Good morning, sir.
Good morning, everybody. So, as you know that in last class we studied verification of law of conservation of energy for a freely falling body. So, I hope you all learned that. So, if you have seen that, everybody, so today's class, I want to make you like a graphical representation of this freely falling body. That is what the conservation of the energy of a freely falling body. When we represent in the form of a graph, how the graph will varies with respect
So,
to yes, Par.
sir, if the energy is against the gravitational force, sir, so the
Hmm.
formula can be mgh.
MGH only, that's what we have done last, correct?
Yes, sir, whatever the energy is, whether it is kinetic or
Kinetic
potential
energy or
energy.
potential energy at a given height, that is what. Okay.
If it is against the gravity, it's mgh.
MGH. That's a proof you have to do it. Simply you cannot say understanding. That proof
Yes,
we
sir.
have done.
No,
So,
sir, if they ask in
yeah,
numerical.
numerical, yes, yes. Law of conservation of energy. So, law of conservation of energy for a freely falling body. So we have been proved if you take at the initial position of a mass m and after traveling a certain distance, that is what x, so it will reaches to a position b and then c position, that is what before touching the ground. So at every cases we have calculated total energy. What is the total energy? We also call it as, all of you, total energy also call it as mechanical energy. So mechanical energy is remains what? Is remains constant. So that is only call it as law of conservation of energy. So at every point, you take any point, you take even 100 points from the certain height of freely falling body. So everywhere, the sum of the kinetic energy plus sum of the potential energy, which is equals to total energy. But everywhere energy remains constant. But somewhere, if you take the maximum height, it has only what energy? Everybody. It has only potential energy. Before touching the ground, it has only what energy? Everybody. Kinetic energy. But the kinetic energy, which is equals to also mgh, here the potential energy also, which is equals to what? Everybody. mgh. Understand? So that is what we have been done the proof also. So those who have not done and those who not learned, so kindly learn that proof. It is very, very important. Definitely it will come in even in exams. Okay. So now today's class, what is our purpose is we are going to make a plot a graph for this freely falling body. Okay. So now if we speak about this law of conservation of energy, we are hearing about the three energies. Can you tell me what is the three energies? What is the three types of energies you are getting here? One is potential energy. Next one is what? All of you? Yes. Next one is kinetic energy. And the next one is sum of the potential plus kinetic, which we used to call it as a mechanical energy. So now we all knows that mechanical energy is equals to what is that, everybody? Sum of the kinetic energy plus sum of the potential energy. That is what? Half mv square plus mgh. So now for a body Now, what is our target is? So let us make the variation of potential energy with the height, variation of kinetic energy with the height, variation of mechanical energy with the height. Now, generally, let me explain. For example, some boy has been thrown a ball in an upward direction, thrown up. Now, generally, I am asking you, tell me, at this point, the body is having only one energy. Anybody can tell me? He has been thrown up. He has only one energy. What energy? Thrown up.
Potential.
Potential energy. Yeah. Wow, great, super. So what energy? He has been thrown with the velocity. Final velocity becomes 0 and initial velocity is maximum. So now you tell me, thrown up.
Kinetic energy.
Kinetic. So when the ball is thrown up, here it is having, let me take EK1, sorry, yeah, EK1, and let me take P, potential energy is EP1. So it is 0 secondary thing. Next, it is reaches to the maximum height, Now here also, it is, let me take, kinetic energy is EKN and potential energy is EPN. Now at maximum height, velocity is 0. So that somebody is 0. What is that? Kinetic energy is 0. Here, potential energy is 0. Is it right, guys? Will you all agree with me? Yes or no?
Yes, sir.
Yes, no. All of you observe very carefully. Let me take, this is the initial point. Next point. Point number 2. This is, let me take point A and this is point B. Now point B, you tell me, kinetic energy to reaches from point A to point B, kinetic energy will decrease or increase? Kinetic energy will? Yes, please. Decreases. Am I right? Velocity decreasing, correct, guys? Velocity, when you keep on going up, velocity decreasing or increasing up? When you are going up, velocity keep on decreases or increases? That was the question.
Decreases.
Velocity decreases. So velocity decreases means kinetic energy decreases or increases? Nivedan?
Decreases.
Decreases. But by this time, there is little increase in the potential energy. Am I right? All of you? Yes. Next. He reaches to the next height. Let me take that point is C. Now coming to B to C, kinetic energy is more decreases or more increase, little increases? Kinetic energy compared to B to C. B to C, next
More
level
decreases.
has been, again kinetic energy decreases. By the time again, potential energy little bit increase. Next point, D point, there is again decrease in kinetic energy because velocity decreases, but height increasing. So that what will increases? Potential energy increases. Do you understand, everybody? Again, it has been gone to the next point. Let me take E point. E point. Now you tell me, what will happen, everybody? Again, kinetic energy decreases. Again, potential energy increases. Reaches to the maximum height. So by that time, kinetic energy become what? Kinetic energy become what? All of you? 0. Because maximum height velocity is what? Velocity is what? 0. So half mv square, v becomes 0. So that entire kinetic energy is 0. Maximum height, potential energy, which is equals to mgh. So height is maximum. So potential energy is what? Maximum. Do you all understanding, right? Everybody?
Sure.
Yes, please. Now, at this point, I will add what is the total energy or mechanical energy is equals to kinetic energy plus potential energy. Now, at this point, the total energy remains what? Every level, at every point, mechanical energy is remains what? Anybody? Mechanical energy remains what? Please respond. Remains constant. Do you understand, all of you? So whatever the height you take, this height or this height, or this height, every height, the mechanical energy remains what? All of you? Constant. Are you clear, everybody? So now if I draw the graph, variation of potential energy with the height. So height increasing, potential energy increasing or decreasing? Everybody. Potential energy increasing or decreasing? That is the first question. Everybody?
Increasing.
Increasing. So let me draw the graph. Height versus potential energy. Height, x-axis, and potential energy, y-axis. So now, height is directly proportional to potential energy. So, H keep on increases. H keep on increases. Potential energy also keep on increases. So, that is what is the graph per height. So, note it, everybody. Height, variation of potential energy. Variation of potential energy with height. Purima, ellame. Do you all understand, everybody? Please respond, guys. So draw neatly. Anybody having any doubt, you can ask. Clear? Understand, Amma? All of you? Yes? So height increases, potential energy also increases. So I will say potential energy is directly proportional to height. So both are directly proportional to each other. Do you all clear? Yes? Please respond.
Yes, sir.
Yeah.
Sir, according to this, can we say that potential energy is equals to our kinetic energy?
Where?
In the case
Mari,
of
you see, basic thing you don't forget. I am talking about only now potential energy. Whatever the kinetic energy loss, which is equals to gain in potential energy. Energy cannot be destroyed, it cannot be created. Only it can be transformed. Do you understand what I'm saying?
Sir,
Try to
yes, sir, I'm
calculate.
asking in the case of free
Yes.
fall, sir.
In the case of free fall also, in the case of free fall, the amount of potential energy lost by the body is equals to amount of kinetic energy gained by the body. Do you understand?
Yes, sir.
Yeah, I will say you just wait. So now this graph you understood or not?
Yes, sir.
Yeah. Everybody, any doubt? Are you clear, everyone? Prithvi? Niroshi? Join with the number, Niroshi. Yes, everybody clear? So now, if I take, see, this is what thrown up. Now you draw the graph for kinetic energy. So now you tell me variation of kinetic energy with the height. So height is increasing. Kinetic energy, what happened? Height is increasing. Kinetic energy. Kinetic energy decreasing or increasing or? Height is increases.
Decreasing.
Decreasing. So initially less height, maximum kinetic energy. Maximum height is increasing, the kinetic energy decreases. So that is what it is. All of you make it. Height increasing, the kinetic energy become decreases. Both are inversely proportional to each other. Kinetic energy is inversely proportional to height. Purima, Mare.
Yes, sir.
So height increases, kinetic energy decreases. Make it, everybody. Understood, Amma? All of you? So variation. So what is the graph? This one. Variation of. See why the graph, sir? 9th class graph not at all needed for our exams. But what it will gives you, it will gives us the idea of how the questions can be like what we can say is the future. How everything will be in the form of graph. Now it will be like a step forward to make a graphical representation of any kind of information. So that's the reason, like cultivating your mind towards to that future aspects. That is what is this? Future everything will be in the form of this. 11th if you goes, if you come to even 10th, every information you have to represent in the form of graphs. Because questions can be from the graph. Always the way of asking question from the graphical representation. So that's the reason we are developing from that. So variation of potential energy with height. What we are not learning anything new from the graph. Do you understand? So what just basic mathematical graph, we are representing the what we learned, that's all. Okay. Now, if you observe this potential energy increasing with the height, kinetic energy decreasing with the height. Now, if I draw a graph for mechanical energy versus height. So what will happen? Mechanical energy at every height, sum of the kinetic energy plus potential energy remains constant. That is what I can take, total energy or mechanical energy. So please write it. So what will happen to mechanical energy? It remains
Constant.
yes. So remains constant means anybody can tell, mathematics you might be have drawn how the graph will be. Remains constant. Remains constant. Anybody? Remains constant. How the graph will be? Anyone? Note it, everyone. Remains constant. Yes, Mr. Lingesh, very good. I have taught you many times in graphical representation of motion. Don't say me if you're not. Chapter number 1. We have studied the graphical representation of motion. So if there is no change in acceleration, have you noticed that constant velocity? What is the graph? Anybody can tell now? Constant velocity graph. VT graph, parallel to x-axis. Remember now, acceleration is 0. Everybody? Parallel to x-axis.
Yes, sir.
Acceleration is 0 because velocity remains constant. Same thing. Mechanical energy never be changes. Always remains constant. But only kinetic energy can be converting into potential energy when you have been thrown up. Thrown up. When it is a free fall, potential energy is converting into kinetic energy, but total energy remains constant. So our graph will be parallel to x-axis. That is what you have to remember. Parallel to x-axis. Note it, everybody. Anybody having any problem, you can ask me. See, the creativity mind has to grow. That is the only thing I'm expecting from everybody. So start thinking. Any doubt, anyone let me know, or else we'll proceed further. So this is what is the graphical representation of, write it, variation of potential kinetic mechanical energies with the height. So what is the name of this graph? Variation of mechanical energy with height. Mechanical energy with the height. Okay. So this is what you have to remember. Write it. Any doubt? Anybody can ask. Okay, guys. All of you.
Yes, sir.
Yes. So now I want to make you a statement. So let us make the conclusions what we have been done in the last class. So if you see that, all of you, we have been made that 3 different points I have taken. Point number A, and after certain distance of x meters, it has been reaches to the point B. After again h minus x distance, it has been about to reach the ground. That is what imagining I am about to touch the ground. So now, if you have noticed it, everybody, so write a statement. It is a free fall. So what I want to say you means free fall. If it is, remember, at any height, when the object is in free fall, at any height, the potential energy lost by the body the potential energy lost by the body is equals to kinetic energy gained by the body. Do you all understand, everybody? Gained by the body. For example, let me take the initially body is having a potential energy of 100 joules. How many joules, everyone? Potential energy of 100 joules. Now, it has been total journey, it has been traveled. Let me imagine total height is 1 meter. What is the total height, everybody? Total height is how much? 1 meter. Understand, Amma? So, or else you take it as a, for example, let me take 3 meters. So 3 meters I'll consider. Now, if it will comes to here at this height, for example, the potential energy at this height I calculated, the height is something, let me take. At this height, the potential energy become 80 joules. So means in the sense of how much is the kinetic energy at this point? Anybody can tell? What is the kinetic energy at this point? At this point, kinetic energy is 0 because maximum height. Then at this point, what is the kinetic energy? Potential energy is 80 joules, which is equals to what? Kinetic energy gained by the body. What is the potential energy decreases? What is the potential energy decreases?
20 joules.
80, 20. So kinetic energy gained by the body is how much?
20 joules.
20 joules. Another point, potential energy become, for example, 50 joules. Then what is the kinetic energy?
50 joules.
Kinetic energy also 50 joules. Do you all understand, everyone? So,
Yes, sir.
the potential energy lost by the body, which is equals to kinetic energy gained by the body. That is what you have to remember. Understand, Kavya? Alfin? Abhirami? So, it's very, very important concept. So, the potential energy lost by the body is equals to the kinetic energy gained by the body at any height of the free fall. That is, you have to remember, at any height of the free fall, the potential energy lost by the body is equals to the kinetic energy gained by the body. Is it okay, guys? All of you? Yes, please. Yeah. So please make sure you understand this statement because this is very, very important one. Okay. So same way, if I have been thrown up, if an object is thrown up, okay, now as we know, initial velocity is maximum. After reaching to the maximum height, final velocity become what? 0. Now, let me take initially the kinetic energy is, now I am taking 100 joules. Now, at this height, what is the potential energy? Everybody, 0. Clear? Now, after reaching to the certain height, thrown up, after reaching to the certain height, kinetic energy become, for example, 80 joules. Now tell me, can you tell me what is the potential energy of the body? 20 joules. Understanding? So that is what it is. So write the statement. When we thrown up, the kinetic energy lost by the body, at every point is equals to potential energy gained by the body. Clear, everyone? All of you? That is what I want to say. So, but totally sum of the potential plus kinetic, total energy remains
Constant.
That is what you have to remember. Okay. So till here, anyone having any doubt? So this is the points regarding the free fall and as well as vertically thrown up. Whatever it is, doesn't matter. Law of conservation of energy. With verification, you have to follow this approach and you have to solve it also. Am I audible, everybody? All of you?
Yes, sir.
Yes. So the graphical representation is the major one while we are answering the CBQs, competency-based questions. Next year you will experience it. Now the term is not familiar for you. So the next year the term will become more familiar. competency-based questions. So this graphical representation will be very, very crucial for every concept, like this physics mainly. So make sure any doubt, anybody can ask me till here, or else we'll go to the next one important point. After that, I'll go to that. So we'll start, everybody. So the most important point I want to say you. So let me take, for example, it is a free fall or thrown up, doesn't matter. Total height I will consider as a h. What is this, everybody? Total height is how much? H. Purima? Now, exactly at half. Half means what is the distance? Everybody? H by 2. And down also h by 2. Exactly half. So write it, everybody. At a height h by 2, at a height of h by 2, kinetic energy and potential energy are equal and both equal to half of the total energy. Kinetic energy are equal and both equal to half of the total energy. What is the total energy? Call it as. What is the total energy? Call it as mechanical energy. Clear, everybody? So what does it mean? So for example, see, if I take in this height, total height, the total mechanical energy is 100 joules. Then exactly at the half, what is the kinetic energy? Exactly at the half, kinetic energy is 50 joules and potential energy also how many joules? 50 joules. That is the statement. That is the meaning of. So exactly at the half, kinetic energy and potential energy are equal. They are the half of the total energy. That is what is your problem. Okay, guys, everybody clear? All of you? Do it fast. You understand? Hello? Any doubt, anybody can ask me. Okay, guys. If it is completed, then we'll proceed further. Okay? Write it. Half means at the half height. The total journey, if you reaches to the half of the height, then potential energy equals to kinetic energy. That's what you have to remember. Okay? Yes? Yeah, proceed. Make it quick. Any doubt you can ask. Understand this darshana, prarthana, Mr. Jai Krishna. Any doubt? Clear? Prithvi,
Yes, sir.
Dan, Princey. You're all okay, then we'll proceed further. Okay? So this is all about the energies. Then we are going to do the next one. That is what the last concept of this chapter. That is only rate of doing work. That rate of doing work, which we used to call it as a power. Power. We used to call it as a rate of doing work. So exam, be very careful. If they ask us to calculate the work, you have to calculate work only. But if they want to calculate the power, they won't ask you to calculate the power. They will ask you to calculate the rate of doing work. So if they are saying rate of doing work, what does it mean? It is asking us to calculate the power only. Do you understand? That is very, very important. They are asking us to calculate the power. That is only the meaning of rate of doing work. Okay, everybody? Clear? All of you? Yes? Okay, so right. So now, so what is this rate of doing work and how to calculate? That is all we are going to discuss. So consider a situation. Let me take, there is a 500 liters tanks. So 2 water tanks where the maximum capacity is how much? What is the capacity? Capacity means volume. Please write it. So capacity is equals to 500 liters. So there is another container where the capacity is also 500 liters. Now, I will say, let me arrange the steps so that they can go. So I will say, for example, let me take Mr. Lingesh. So Lingesh to, I will provide one bucket and I will ask him to fill this 500 liters tank by taking the water with the help of a bucket. By taking the water with the help of a what? Bucket. Now this one, I connected to a motor directly the pipe. I connected to a motor. Okay, everybody. And I on the switch. I on the switch. Okay, wow. Now, you tell me who will fill the motor tank fastly with the motor? Motors are non-living thing. Lingesh living thing. Adi considered illa. So both are doing the same work. So Mr. Lingesh is also doing the same work. Mr. Motor is also doing the same work. So motor target is to fill the tank. Lingesh target is also to fill the tank. Now, let me take Mr. Lingesh has been taken, for example, 1 hour to fill the tank. The time taken by Mr. Lingesh is 1 hour. But what is the total work done by Lingesh? Remains same. What is his work done? Filling the 500 liters only. Am I right, guys? Respond,
Yes,
everybody. So same
yes,
tank,
sir.
same capacity of a tank. Mr. Lingesh is filling the 500 liters. So what is the total work done by Mr. Lingesh is equals to something X. Let me take. Now Mr. Motor is fill the tank. Just let me take within 15 minutes. I don't think so require that much also. Just I'm considering it. So now I will compare Mr. Lingesh and Mr. Motor. Now you tell me, both has done the same amount of work. Do you all understand, everybody? Am I right or wrong? Please respond. All of you? So Mr. Lingesh also done same amount of work done. Mr. Motor also done same amount of work done. But what is the only difference? Anybody have noticed it? What is the difference between Lingesh and Mr. Motor? Any one of you? What are this much poor people? Time. Mr. Lingesh is taking 1 hour to fill the tank. And Mr. Motor is filling the tank within how much time?
3 minutes.
It is based on the amount of power supplied, sir.
That power supplied not. That is what I will say. Don't think too much it is generally. So I'm not saying motor is running with electrical energy. Feel like motor is also a person. So what will happen, everybody? Mr. Lingesh is taking 1 hour time to fill the tank, but Mr. Motor is taking just 15 minutes to fill the tank. So here we can say that the amount of work done is remains equal, but per unit time, work done per unit time is very, very important. So who has done more work in less time? More work in less time. Who has done? Motora, Lingesha. More work in less time. Unit time. Yes, please. Who has done more work?
Motor.
Motor. So that is what is the physical quantity which will tells how fast or how slow work is done per a unit time. Work is done